So this is a presentation on specific heat capacity. There is a question and the answer as well. So what is specific heat capacity? It's the energy required to raise 1 kilogram of a substance by 1 degree C. It's often written as the letter C, a small case, which is confusing because light's also written as the small case c. But the equation obviously is different. Equals delta E divided by m delta T. So what are these terms? Well, delta E is the change in energy. That's in joules. M is the mass in kilograms. Delta T is the change in temperature, and that's in degrees C. Now you can rearrange that equation to give us E equals, have a go yourself, and then I'll carry on. So you should get E equals mc delta T, but the other way of writing delta T, often seen, is just with a theta. So the change in temperature is the theta. C is the specific heat capacity, not the speed of light in this occasion. M is in kilograms, and E, as we've said before, is in joules. So let's have a look at the question. If you want to pause it now and have a go at the question, I'm going to do it in two parts. I'm going to go through some of the pitfalls, and then I'm going to do the answer to the question. Okay, so if you want to start, off you go. If you want to hear the pitfalls first, I'll start those now. So specific heat capacity of water is 4.2 kilojoules per degree C. Calculate the energy required to raise the temperature of a cup of water, 250 millilitres, from 20 to 35 C, assuming no heat is lost to the environment. C equals 4.2 kilojoules per degree C. Changing that, you get 4,200 joules per degree C. The mass, well, it's 250 millilitres, and water is 1 gram per milliliter. So the mass goes from 250 grams to 0.25 kilograms. Next, we've got the temperature change, theta, and it's worth noting that this is positive. The final energy will be greater than the initial energy because it's hotter. So we get 35 minus 20, which equals 15 degrees C. Now we've got all our units correct. So if you want to pause it here and have a go at answering the question, please do so. If you don't, I'm going to carry on. So now we write the equation down. E equals mc theta. And I'm going to substitute the numbers in for the letters directly underneath where I've written the letters. So the m is 0.25 times the c, which is 4,200, times delta theta, which is 15. So now we've got E equals, and we have to push those numbers into our calculator, and when you do that, you should get an answer of 15,750 joules. Almost there. The next thing we need to do is write this to the correct number of significant figures, and you should look at your question to get that, if it doesn't tell you already. So we've got 4.2 here, that's two significant figures, 250, that's two significant figures, and the raising temperature is also two significant figures. So in two significant figures, it's 16,000 joules. But the answer needs to be in kilojoules, so you should get 16 kilojoules. So here we go. Answer, correct, kilojoules is worth a mark. The equation is worth a mark. The substitution is worth a mark. There is no mark on this for the units because the units have been given to you, but there is a mark available for working out the correct formula above. So what you should have, this should be out of 1, 2, 3, 4 marks. 4 out of 4. Okay, thank you very much. I hope you found this useful.